All right, so the last section we're going to look at this week is 3.3. It's on, they call it the factor theorem. What we're really, that's the title of it in the book. But we're going to really be looking at the remainder theorem and long division. Okay, those are the two things. So just a couple reminders about what these terms mean. So if I say the word 0 or I say the word root, then that means it's a number that you can plug into an equation and you get 0 as the answer. So for example, y equals 2x plus 6. If you can find the number you would fill in for x there, do it out and it comes out to 0, that is the root of that equation. What number could you fill in for x? And it would come out to 0 when you do it all out.
-3.
Yeah, -3. So -3 is called the 0 or the root of that equation. Because when you plug it in, it comes out equal to 0. Okay. Now, that one wasn't too hard to find the root because it's linear. Right? Linear equations, you pretty much, that's what you learn to solve in Algebra 1. You just set it equal to 0, and it only had 2 steps, which you could pretty much, most of the time do in your head for that kind of problem. Minus the 6, and then divide by 2. But what if we had something like this, like x squared plus 5x plus 6? You might not be able to look at that quickly and figure out the 2 numbers you can plug in to get 0, because it's a little more complicated. It's a quadratic. So we're going to look at how can we take that and make it simpler so we can figure out the numbers you can plug in and get 0. And one of the approaches we're going to use is going to combine long division and factoring. So let me show you an example with just numbers first, not a polynomial with letters, but just numbers. So let's say that I want you to factor the number 12. That means I want you to write 12 as a product of 2 numbers. And I'm telling you one of the numbers I want you to use is 3. How could you figure out the other factor of 12 if you know that 3 is one of them? Like how could you figure out the question mark?
Divide 12 by 3.
Yeah, you could just take and divide each side by 3, and you would get 4. Okay? So if you want to factor the number 12 and you want to use 3 as one of the factors, that means 3 times something. I used the question mark, but 3 times something is going to give you 12. Dividing each side by 3 gets the question mark by itself and gives you the answer of 4. So now we know how to factor the number 12. It's 3 times 4. So as long as you know one of the factors, you can divide it into the number and get the other one. And I want you to think about what just happened here. I told you that 3 was a factor, and you divided it into 12. When you do long division, what's the remainder when you divide 3 into 12? 0. Okay. So anytime that you divide something into something else, if it is a factor, it will go in evenly. Okay? You will not get a remainder. So like if I tried to divide 12 by 5, well, it doesn't go in evenly. I get a remainder. Because I get a remainder when I try to divide 12 by 5, that means 5 is not a factor of 12. Okay? Remember, factor means you can multiply 2 numbers that are not decimals together to get the number you're looking for. Those are factors. All right, so that's going to be really important. Remainder of 0. So what that really means is if we can figure out a quick way of finding out if a remainder comes out to 0, then we have a quick way to figure out if something is a factor of something else. As long as we can figure out what the remainder is quickly. All right. So that's one thing we're going to look at today. How can we quickly find a remainder? And the way that I'm going to show you, it doesn't work all of the time. But it works in a situation that comes up a lot. So that's why I'm going to show it to you. That's basically what I just said to you a minute ago. If you divide two things and you get a remainder of 0, then what you divided by is a factor. All right, so if I take 50 and I divide by 10, I don't get a remainder. 10 goes into 50 exactly 5 times. And because I don't get a remainder, that means 10 is a factor of 50. Now, if I try to take 50 and divide by 12, that doesn't work. I get a remainder. And that's because 12 is not a factor of 50. So the reason why we want to know how to factor something and figure out what it is something a factor or not a factor is because then I can take a problem like this. And as long as I know how to factor it, I can quickly turn it into this. Now, looking at that, I can tell you my two zeros very quick. If I plug -3 in, I get 0 there. And if I plug -2 in, I get 0 there. Okay? So it's much easier to see the numbers you can plug in and get 0 when it's factored versus not factored. That's why we factor. So we're going to look at that same process we just did with the number 12, okay? Looking and seeing if something is a factor of it by doing division. Right? And we just have to keep track of the quotient and the remainder. Okay, well, really, the remainder is that's the important part. All right, so what I'm going to do is we're going to do a division problem, and there's 5 steps. As I show you a step, I'm going to do it off to the right. So the first step is more of setting the problem up. So what you want to do is look at your dividend. Your dividend is what I just underlined in red. The divisor is what's underlined in blue. That's on the outside. You could also call them numerator and denominator. Okay? But when we write it like that, it's usually divisor and dividend. And the first thing is, if you are missing any terms, you need to fill in zeros for those terms. And what I mean by missing is, if your highest term is x cubed, you need to have every term from an exponent of 3 all the way down. Exponent of 2, exponent of 1, and then exponent of 0, which is just the constant. So am I missing any terms in my dividend?
X squared.
Yeah, so I need to fill in a 0 for that because I need a column for things that have an exponent of 2. Right now, I don't have a space for it. So I'm just going to copy this over again. I'm going to do x cubed. And again, adding 0x squared, that doesn't change the problem because you're just adding 0. But what it does is it physically gives us a space now for a column with the exponent of 2. So that's why we do it. We need the space. Okay. When you do a long division problem, the work is going to go down to the right. That's pretty much how it kind of goes because of the way we do it. So you want to start a division problem like closer to the left or in the middle, but don't start it right on the right edge. All right. So now, step 2. You're going to take the first term of the divisor, which is x, and you're going to divide that into the first term of the dividend. So right now, you're not doing anything with the minus 3. We're just leaving it. Okay, we'll do something with it in a second. But take the first term of the divisor, which is x, and divide that into the first term of the dividend. So off to the side, I wrote down what I'm kind of doing here. I'm doing x cubed divided by x. And what do you get if you do x cubed and you divide by x? If you're not sure, think of it like that.
X squared.
Right, you get x squared because you have 3 x's in the top. You got 1 in the bottom. So you can cancel 1 from the top and the bottom, and that leaves you with x squared. Okay, any question on how we got x squared? Okay, so now the next step. We're going to take the answer that we just got in step 2, the x squared, and you're going to multiply that out to each term in the divisor. It's kind of like a distributive property, like that. So multiply the answer that we just got by each term in the divisor, and we want to make sure we put the answer in the right column. So if we get exponents of 3, those are the first column. Exponents of 2, that's the second column. Okay, so let's multiply that out. What's x squared times x?
X cubed.
That's x cubed. And what's x squared times negative 3?
Negative 3x squared.
Yep. And that's why we needed a column for x squareds, because we wouldn't have had a place to put that. So that's step 3. Distribute that answer back out and put it in the appropriate column. Okay. Questions on that stuff? All right, so now step 4 is to subtract the columns that we just made in the last step. So the way I do that is I put a minus sign, put all of that in parentheses, and we're going to subtract our columns. Okay, so what's x cubed minus x cubed? Nothing. When you do long division, you should always get something that cancels out like that at this step. Okay, so x cubed minus x cubed is gone. What's 0x squared minus negative 3x squared?
Negative 3x squared. 3x squared.
3x squared, because that's minus a negative.
Yeah.
So that's 3x squared. Okay, and that's step 4. So now we have to just keep doing that until we're done. Okay, but that's the process. How do you know when you're done? Well, this x has an exponent of what? This one that's in blue on the outside. Yeah, it has an exponent of 1, even though it's not written. You have to keep going until this number is smaller than that number. Or you get a remainder of 0, in which case you're also done. Okay, so we're going to bring down the next term, which is negative 8x. And we're going to keep going until the exponent, which we call the degree on the inside, is smaller than the degree on the outside. Okay. So now, to start off your next step, you're going to take the first term on the outside, which is x, and you're going to divide that into the first term on the inside, 3x squared. So think of it as 3xx. Okay, what do you get when you divide x into 3x squared? 3x. Yep. Okay, so you get 3x. Now, what do I do with the 3x? Yeah.
You subtract a few 3x,
Not yet. We're going to do subtracting of columns, but we skipped a step. We don't have any columns to subtract here yet. Yeah?
You multiply it by the x minus 3.
Right. We're going to multiply that back out to the x minus 3. X minus 3. What's 3x times x? 3x squared. Good. And what's 3x times negative 3? That would be 3x times negative 2. Yeah, good. Negative 9x. Okay, so multiply it back out. Now we're going to subtract our columns. What's 3x squared minus 3x squared? Zero. Yep, that's gone. And what's negative 8x minus negative 9x?
Negative 17x. Oh, wait. Never mind.
That's x. Why is it just x?
The negatives cancel.
Right. That becomes negative 8x plus 9x. So negative 8 plus 9 gives you positive 1. Okay. Now bring down the next term. And what's the exponent of my x now on the inside? That's a 1. What's the exponent of the x on the outside? A 1. So now they're equal. We got to keep going until it's smaller. Okay, so this is our last time. All right, so you're going to take x on the outside and divide it into the x on the inside. And what do you get? 1. Okay, what do we do with the 1? Distribute it back out. So 1 times x, 1 times negative 3. And now what do we do with those columns? Subtract. What's x minus x? That's gone. And negative 3 minus, positive 3 minus minus 3. 6. And what do you think that 6 is? That's your remainder. Okay, so when you write your answer, we can write the quotient. Okay, that's the part that's up there, x squared plus 3x plus 1. And the remainder is 6. And that's how you can write your answer. Right? If they ever ask you to write your answer in a different way, we're going to do it that way. And I'll check the homework for the directions and I'll remind you of that.
And wouldn't it be negative x because you subtracted negative, or I'm confused on the 8x or negative 8x subtracted by.
So that's negative 8x
Yeah.
It'll be easier if we weren't.
plus
Oh, no, okay.
9x.
Yeah, so I'm about to tell that.
Yep.
So you're sleeping.
I understand. This is just
Okay, any other questions on that one?
Yeah.
So now,
Wait, no, we didn't.
if I asked you, is x minus 3 a factor of x cubed minus 8x plus 3? What would you say? Guys, go ahead. What would you say? Is x minus 3 a factor? Why not? Because there's a remainder. If something comes out with a remainder, then what you divided is not a factor. So if you wanted to know what is a factor, well, that's a little different. But we know that's not a factor. Yeah.
Will we have to like do this process over and over again, like guess to find the factors?
No, if we were going to actually find them, we would do something a little different.
Okay.
Yeah.
Just checking. 'Cause
There's,
that's-
yeah, there's different things we can do to not have to do that.
Okay.
Yeah. All right, let's try another one of those. So this one, I've already set up the way that it should be for you. They didn't put anything in for x squared or x. So we put in zeros. Okay, so we've got 2x squared plus x plus 1. And we're going to divide that into 2x to the 4th minus x cubed plus 0x squared plus 0x minus 2. Okay. Chase, what's my first step that I'm going to do? I'm going to divide what into what?
You divide 2x, 2x to the power of 4 by 2x to the power of 2.
Yep. So 2x to the 4th by 2x squared. And again, if it confuses you with the exponents and you're not sure, then just write it out like this. This takes a lot longer, but then you can probably see what cancels out easier. What's left when you divide those two things?
2x to the second. Oh, wait, x to the second.
Yeah, the 2's are going to cancel, and 2x's in the top and 2x's in the bottom. So you're left with 2x's in the top. Okay, so we get x to the second. What do we do with that x to the second now? Yep, distribute it out. What's x to the second times 2x to the second? Yeah, it's always that one. So 2x to the 4th. X to the second times x.
X to the third.
X to the 3rd. And x to the second times 1.
1x squared.
Yeah, just 1x squared. Okay, so we got our columns set up. What do we do with all of those? Subtract. Okay, 2x to the 4th minus 2x to the 4th, that's gone. What's negative x cubed minus x cubed?
2x cubed.
Negative 2x cubed.
Negative 2x cubed. So that's like a negative 1, and then you're minusing another 1 from it. So that's a minus 2. And 0x squared minus x squared.
Negative 1x squared.
Yep, negative 1x squared. Okay, what's the degree on the inside now? 3. That's the highest exponent, so it's a 3. What was the degree on the outside? 2. We got to keep going until that number is smaller than that number. Because once it's smaller, then what's on the outside won't divide into what's on the inside. Okay, so even though the next term is a 0, we're just going to bring it down as a placeholder. Okay, what's the next division that I'm going to do to start my next round? Yep. So negative 2x to the 3rd. Okay. 2x to the 2nd. So x's are gone. 2's are gone. We're left with negative x. Yep. Okay, and now the negative x, what am I going to do with that? Distribute it back out. That's going to give me negative 2x cubed. What's negative x times positive x?
0. Oh, wait, no. Negative x squared.
Negative what?
Negative x squared.
Negative x squared. And what's negative x times positive 1? Negative times positive.
Oh, I keep forgetting about this.
Negative x.
Negative x. Yeah, there's a lot of little things here. Okay, now take those columns and subtract. Okay, what's negative 2x cubed minus negative 2x cubed? That's 0 because it becomes negative 2 plus 2. What's negative x squared minus negative x squared? That's also 0 because that's negative x squared minus a minus becomes a plus. What's 0x minus negative x? X. And now we bring down the next term. What's the exponent on the x on the inside? It's a 1. And on the outside, it's a, yeah, so now we're done. Because you can't divide what's on the outside into the inside. There's not enough x's
So
left.
that'll be the remainder.
So that's the remainder. Yep. So when you write your answer, quotient 2 2x squared plus x plus 1. Remainder, x minus 2. So now, if I asked you, is this a factor of that? What would you say?
No.
No. If it was a factor, you would have gotten a remainder of 0, but you didn't. Okay. Any question on that one?
I thought the quotient was on, what's at the very top?
Yeah. Oh, yeah. Jeez. Thanks. Yeah, the quotient is always what's on the very top. I wasn't looking quick at the right spot. X squared minus x. Yes. Thank you. So yeah, the quotient is x squared minus x, and the remainder is x minus 2. I was already thinking about my next question I was going to ask, so sorry. Okay, so yeah, any questions? Is that what other people are going to say too? Yeah. Okay, so okay, so I want to show you a quick way that you can find a remainder, but it doesn't work in every problem. Okay? In this last problem, it wouldn't work. If you wanted the remainder here, you'd have to do what we just did. But if you wanted the remainder for example 1, this theorem I'm about to show you, it would find the remainder. So, first of all, the remainder theorem only works. It doesn't matter what you have in the top. That's fine. You can have anything you want in the top. But the bottom has to be x minus a number. Okay? X minus 2, x minus 5. It has to be x to the first power minus a number. That's why I said it would work in this first one, because that's x to the first power minus a number. That's not x to the first power. Okay, so it would not work. So the remainder theorem says that if you want to find the remainder, this is what's in the top. Just write that right there. F of x is in the top. And you are dividing by x minus c would be in the bottom. What's in the top doesn't, again, that doesn't matter. It could be anything. But whatever's in the top, if you divide by x minus c, the way you can find the remainder is take the number after the minus sign, not the minus sign itself, just the number that comes after it, and plug that number into the top. So you take the number after the minus sign, you fill it into the top, and when you do that, it'll give you the remainder. Okay, now I'll show you how that works on the first problem. Okay, and I don't know why a lot of people seem to have trouble with it. I don't know if it's they just forget, you know, because we're doing it on Wednesday, and then by the time Friday rolls around, they're just not remembering it. But it's a pretty straightforward idea. Just take the number after the minus sign and fill it into what was in the top. So let's look at this one. This problem fits the pattern that you can use the remainder theorem. You're dividing by x minus 3. What's the number that's after the minus sign? 3. So we're going to take the number after the minus sign, and we're going to fill it into, this is what would be in the top if we wrote it as a fraction. So fill 3 in for x. You get 3 cubed minus 8 times 3 plus 3. What's 3 cubed?
27.
27. What's 8 times 3?
Negative 24.
So 24. What's 27 minus 24? 3. And what's 3 plus 3?
6.
6. Now let's scroll down and see what we got for a remainder. What do we have for a remainder?
6.
6. Same thing. Yep. So it's a quick way to figure out this number. If you need this, then you got to do the whole thing. Okay, if you want to know the quotient, you got to do long division. But if you're dividing by x minus a number, and all they want is the remainder, you can do this shortcut. Okay, but remember, it has to be the number after the minus sign. Just the number, just the 3. Yep.
So on the test, will there be questions asking for what the remainder is, or?
Yeah.
Okay.
Yep, and I might give you some like really large exponent, like 42. So it's something that's so large you couldn't do the long division because you'd need 42 columns to do it. But if you use the remainder theorem, you can do it in under 10 seconds. You can do it as quick as we did that one. Yep. All right, so let's try, I think I have another one of those. Okay, so let's try this one. I want to divide f of x by h of x, and then I want to divide it by g of x. So it's 2 different problems. And all I want is the remainder. Okay, we'll talk about g of x in a second. You might think, wait a minute, you said it has to be x minus a number? Hold on 1 second about g of x. Let's start with f of x divided by h of x. So in the top, you've got x cubed minus 2x squared plus x minus 5. And we're dividing by x minus 3. Does this first problem fit the pattern that it's supposed to use the remainder theorem? Yeah, because we're dividing by x minus a number. What's the number after the minus sign? 3. Take the 3 and fill it in the top. Everywhere there's an x. Okay. So we've got 3 cubed minus 2 times 3 squared plus 3 minus 5. 3 cubed, we just did that a second ago. What's 3 squared? 9 times 2. So I get minus 18. What's 27 minus 18?
9.
So that gives me 9 plus 3 minus 5. What's 9 plus 3?
12.
12. And what's 12 minus 5? 7. That's the remainder if you did out the long division. So now if I asked you, is x minus 3 a factor of what's in the top, what would you say?
No.
No, because the remainder didn't come out to 0. All right. So now let's try it with g of x. So same thing in the top, x cubed minus 2x squared. And the bottom is x plus 1. Okay. Does that one fit the pattern for the remainder theorem?
No.
No. The bottom is supposed to be x minus a number. But could we fix that so it's x minus, and then whatever number would be in that box is the number you would fill into the top? Is there a way we could fix the bottom so it would be x minus something? Yeah?
Multiply everything by -1.
So I need a number you could put in that box.
So like -1.
Yeah. X minus minus 1 is the same as x plus 1. But if you think of it that way, now it's x minus a number. The number in that box is -1. Fill -1 into the top, the number after the minus sign. And that'll tell you the remainder. So technically the remainder theorem works if it's x minus a number or x plus a number. You got to be careful when it's x plus a number to fix it. Any question on how we fix that? Okay, so let's fill in -1. So we've got -1 cubed, 2 times -1 squared, minus 1 minus 5. What's -1 cubed? -1. What's -1 squared?
1.
1 times 2.
-2.
So we get that -2. What's -1 minus 2?
-1. Negative 3.
-3, and -1 minus, or -3 minus 1,
Negative 4.
-4 minus 5,
Negative 9.
-9. So it takes us maybe like 20 seconds. That's a lot faster than doing long division. If you want the quotient, you still have to do long division. Okay, so is x plus 1 a factor of the numerator?
No.
No, because we get a remainder of -9. All right, where did I go with that? Okay, so this will be our last one. It says, just worry about example 4. We're not doing what's up there. It says use the factor theorem, which if you see the directions in the book, if it says factor theorem in the homework, we're going to use remainder theorem. It's basically the same thing. Okay, so use the remainder theorem to show that that is a factor of that. So if that's a factor, I'm going to hope when I divide it into it, I get a remainder of what? I want to get a remainder of 0. Now, do we have a quick way to get a remainder without finding the quotient? Yes. So that's what we're going to do. We're not worried about the quotient, just the remainder. So we've got x cubed plus 5x squared plus 5x minus 2. Now the only problem is it's supposed to be x minus a number. So can we figure out what would be in that box? And that's what you fill into the top.
-2.
Right. We got to think of that as a -2. So now, if you plug -2 into the top, that means that x plus 2 goes into it evenly if you get a remainder of 0. If you get a remainder of 0, that means it's a factor. Okay. So let's try plugging in -2. So -2 cubed, 5, -2 squared. I'm just going to do this part out. 5 times -2 is -10 minus 2. Okay, what's -2 to the third power?
Negative
So -8. What's -2 squared?
4.
4 times 5 gives me
20.
20. Okay, what's -8 plus 20? Or think of it as,
12.
yeah. So that gives me 12. What's 12 minus 10?
2.
2. And what's 2 minus 2?
0.
There we go. So we got a remainder of 0, which means that goes in evenly, which means it's a factor. So we just showed that x plus 2 is a factor. Okay, we don't have much left, but we're going to finish it tomorrow. So I'm going to change the homework a little bit. So make sure if you look at the homework, it's the video from YouTube.
Wait, how many went down? 40?
Yeah, pictures.
Yeah. So I think going down.
Okay, so 1, 2, 4, that's fine. Find the quotient and remainder. 5 and 6 says use the remainder theorem. We talked about that. Number 9, it says use the factor theorem. It's like the last problem we just did. So number 9, just do the remainder theorem. Okay, so just do the remainder theorem. Anywhere you see factor theorem, just change it to remainder theorem. 13. So what I think we'll do, let's just do up to number 13. Okay, so just what I'm putting a box around. Those other ones, I didn't cross them out because that's probably going to be part of what we do tomorrow night. Okay, so for tonight, it's just 1, 2, 4 through 6, 9. And then 13 is a factoring problem. I only did one of those at the beginning, but I want to see if you guys can factor. So just try that.